so we got the file open. I just started the recording, almost forgot. So if you look on this part, like right here is a perfect example. If we were to go and cut this shape out here, those are going to fall out.
Right.
So do we get rid of them, or do we, how do we want to do that? Because you could go in and put like tabs across here to hold them in place, but with something like that, it'd be such a goofy looking thing. I just don't know if it would work.
Right. So like I see this kind of wing here is going to drop. So basically, this is going to be a problem because it's going to be on a drop wing. And
so, and we don't have to really fix anything. What I want to show you is a cool trick that I started doing, well, since we worked last for sure. So if you go up to utilities, we just opened a DXF. The first thing we're going to do is try and get Bobcat to clean this thing up for us. All right. Now, what I want to do real quick, I'm just going to right click and go down to this entity summary here. And I just want to see what kind of entities we're working with. So there's no splines. That's specifically what I'm looking for. I don't want to use splines if I can help it, because there can be imperfections kind of hidden inside of a spline that you or I can't see when we're looking at it in Bobcat. But when you're looking at, when Bobcat's looking at it and it's using the tolerances that it uses to look at this stuff, it can find some problems. So no splines is a good thing. Now, the first thing we're going to do is, do we want to be in millimeters, by the way? Just want to make sure.
It doesn't really matter for our purpose. This one was a stolen image.
What's the machine use?
The machine is set to inches.
All right, let's set this bad boy to inches as well then. And then let me go up into the settings here. Document default inch. All right, display. I'm going to change your background color just to a faint gray. That'll be easier on the eyes over the days, and it actually makes things pop a little bit better. Axis, okay, good. All right, so apply that to the document. Apply, okay. All right, there we go. So I picked up this trick recently. Now, I'm not going to touch these little things. I'm going to leave them there right now. The first thing we're going to do is try and clean up this geometry. Get it as clean as we can get it. And we're going to do that by going up to utilities, and then right here, this little recycle bin here, we're clean up, optimize. What this is going to do is if there's any duplicates, we're going to get rid of them. If there's any entities that should be one piece, but they're broken into two pieces or more, it's going to rebuild those. The benefit of this thing and doing this right at the first step is if there's a problem that it can fix, it'll fix it. If there's no problem, it's just not going to do anything. So there's no downfall. There's no reason not to use this feature. And it's so simple. All you do is go to Clean Up, Optimize. You drag a box over everything on the screen. You can hit Control-A to select all. You could go to the Home tab, and we have a Select All button right there as well. You select everything and hit OK. And so not many corrections. We had 2 lines and 2 arcs. Now, again, that could be one of 2 things. Duplicates, which are dangerous. We hate duplicates, all right, because that's 2 of the same lines sitting in the same place. And it happens all the time with DXF. The other one is there could have just been a broken line, like this little straight line right here. Instead of being 2 pieces, it could have been, or instead of being one nice line, it could have been 2 pieces. And so that rebuild could be us just putting one of those back together. So it's good to see that we had some corrections. That's what I want to see. And then we'll hit OK. Now, this other trick that I picked up is to figure out if everything's going to fall properly, or it's going to help you figure that out. So if I go up here to Create 3D, and I know it sounds weird, but you go to Create 3D, and then right here we have a planar feature. All right, what planar does is it allows me to select flat geometry, like that wireframe you see in this little image here, and it turns it into just a flat surface. So I'm going to drag a box over this whole part. And so you'll see everything that's this yellow shade right now, that's what we want. But if there's something inside of that yellow, like these guys right here, that guy right there, the tongue right there, that little guy there, those are going to stay, or I mean, we just don't need to worry about cutting them. But if I hit OK, you can get a really good visual of what this part's going to look like when it's all done. And honestly, it's a fantastic part. This is a great one for plasma, other than, again, we're just going to go in and pick the things we can't actually cut, which we saw, but I will tell you, there's some parts that you'll do where you look at it and you're like, that should be fine. And then you run it in the simulation, you're like, oh, if I cut that part, the whole thing's going to fall out. Like I did a big Harry Carey logo, the old Cubs announcer. And if I cut his glasses out, then I lost his eyes and his nose. So I ended up having to just connect it, and on his nose, I actually just made some little tabs that hold his glasses in place, and it actually came out really good without too much work. All right, so we have the part in here, and the first thing we're going to do is let's see what size we're working with, and then how big do we want to make it. So I'm going to right-click, go back down to that entity summary. And in here we have, it's 11.89 by 7.7, and we'll get more accurate with that. So how big do you want to make this thing?
Probably 15 by, probably the large dimension would be closer to 30.
So this 11, we want it to go 30 wide.
Yeah.
Perfect. So we're going to take this value here. This is the one that we're determining the rest off of. We're going to scale it, whatever X goes to get to 30, Y is going to do the same. So we're going to scale it evenly. So first thing I'm going to do is I'm going to copy that number. All right, and I'm going to hit OK. Now, scaling is one of the easiest things to do as long as you know how to do it. All right, there's 2 bits of information you need. What size are we currently, and what size do we want to be? If you know those 2 numbers, you can figure out your scale for anything. So if you go up to utilities and you go right here to scale, we're going to do a uniform scale. So that's going to keep everything evenly, X is going to grow and Y is going to grow. That number I just copied, so I'm going to paste that right there. So it's 11.8965. Now I'm going to do this backwards first, but if our part was 30 inches and we wanted to make it 11.8965, we would take that number, excuse me, and divide it by 30. Any number below 1 is going to make your part smaller. Anything above 1 is going to make your part larger. If I make the scale factor 1, nothing's going to happen. So in this case, 0.39, it's going to shrink to 39% of its original size is how you can read that. So with those 2 numbers, I have them. All I did was I put them in backwards. So I got to switch the order of them. So this time we're going to say 30 divided by, and I'm just using Control-V on the keyboard to paste. To paste that number. Now you'll see when we click outside this box and just click anywhere, now we have a number larger than 2. You'll see the preview gets bigger. And then the only other thing I'm going to do is right here we have this scale origin. I'm going to say enter, and that'll keep my work inside the quadrant I want to be in right there, because that's where we want everything drawn.
Of course.
So now if we hit OK, and we cancel out, and we go to our entity summary, we are at exactly 30 inches wide, which made Y 19.6 inches wide, or tall.
Okay.
Pretty sweet, right? Scale's so easy. But, all right, so we got rid of everything we needed to get rid of. That's going to fall out. Some of this might be so small, it might not even cut anyway. It all depends on kind of how we define this. But now we want to just move it. Like right here, we're really close to the edge. We can actually look, if we go to our entity summary here, the minimum in X is at 0.295. In Y going up is 0.295. The minimum in X over here is 1.19. All right. So I'm just going to go and say utilities and translate. And I'm going to say for Y, I'll go 1 minus 0.295. I want the bottom of this thing to sit right at 1 inch. All right. And that'll tell me I got to go up 705,000. Pick the part. It's going to shift up. I'll hit OK. And then if you want to, from here, you can go into your entity summary again and grab this value right here, the 1914. We can copy that, and now we can zero y back out and just say in x, let's go minus that number. And this will just, this isn't something you have to do, but if you're being more accurate with, you know, you got sheets of material, you want to get a lot out of it, you want to be accurate about where you place things. You know, you might even go as far as, look at this section right here. This is, you know, about a foot long almost, probably close to that, you know, 11 inches, 12 inches. And it's, you know, 6 inches, about 6 inches tall. We could fit something in there if we're trying hard enough. You know, you could fit another piece of something in here. If someone wants something small, you could throw it in there. Same with that side. So, you know, getting your geometry in here where it's situated nicely and not right on the edge of the material, because one, the edge of the material might not be perfectly straight, especially if you're using, you know, remnants of material. And you don't want your plasma to leave and then enter back on, because it's not going to have time to, it's not re-piercing when it does that. So you want to make sure you give it a gap around that the tool can go around. You know, just like when you print, you got margins, same thing. All right, okay. So that looks pretty good. I think we're ready to go. So we're going to go over to our cam tree, and I'm going to look at two things here. I first want to go job from template. Did we ever save a template? No. Is this the same computer we used last time, though?
Yes, it is.
Okay, good. So we may have saved something. We're going to find out. So we're going to go here and say new job. We're going milling, but we're going to choose our Bailey. Which one do you guys have? The Rich Auto, the Starfire, or the Fangling? Do you know?
I think we are Fangling. How do I know for sure?
It's somewhere in the controller. I can't remember. It might be on the front of the manual of the controller, honestly, but I can't remember off the top of my head. Either way, whatever it does end up being, if we find out that it's the Rich Auto, all we have to do is after the job's done, we can go and switch the machine real quick. It's not a big deal. All right, so no default parameters. So we didn't set any of that stuff up. All right, so from here, we're going to go into the stock wizard. So we've defined that we're doing this milling job, and I'm going to set this machine as your default here in a minute, and just so it's always there. And then we're going to go directly into the stock wizard. And this is where we're going to define the stock. This workpiece, we're not doing anything with it. This is a solid, this has to be a solid model, so we don't actually have anything to pick. We have no solids. So we're just going to go next. And right here, it's going to make a rectangular piece of stock. Now, how big is your machine? Is it the 4x8, 4x4? What do you got?
Well, it's like a 4x5, but we'll say 4x4 because that's the sheet stock we have.
Okay, perfect. So what I always usually do is I draw out the whole sheet, just because it's easy. But I didn't, like, usually I have a layer where I go in and make a rectangle for it, but we don't need to do all that. If we go in here and we say that our X is 48 inches wide, and our Y is 48 inches tall, and our Z, what's the thickness of it?
Well, let's call it the 8th inch.
Perfect. All right, so there it is. Now, notice this. The stock is not centered. You know, I want this bottom left corner here to be in that position there. And the reason that's happening is this origin, when it gets initially created, goes to the center of our geometry. And so these positions right here are the center of the geometry. We don't want it to go to the center of the geometry. We want to go to the center of the sheet. We want this thing to be located at where the center of the sheet's going to be. It's real simple. You take your X and your Y and you divide them by 2. Whatever those values are is what you punch in here. So 24 by 24, and you'll see that puts the bottom left-hand corner of the sheet right at our origin, which is what we're going to call 0. Standing next to a train, what was that?
Oh no, that's our class change bell.
Oh yeah, I forgot you're at a school. All right, so after we do this, all right, after we create this part, when we hit next right here, it's going to want us to pick our origin. But because we drew our part in this upper right-hand quadrant, and because we moved our stock into that upper right-hand quadrant, we don't actually have to pick anything. We're just going to go ahead and hit OK. And that's it. So now what we can do is right-click on Machine Setup 1, and we're going to go down to our Mill 2 axis. I'm going to blank out the stock real quick. I'm just going to right-click on it here, say blank on blank. It's going to just get out of the way for us. All right, so now we're using one toolpath, but what I'm going to do, Eric, at the end of this thing, I'm going to set this up as a job template. You're probably not going to go much bigger than a 4x8 or a 4x4 sheet normally. The template is editable, but basically what I plan on doing when we're all done with this, we're going to be able to go in and say, I want to load a job from a template. It's going to load in. It's going to have this 4x4 piece of stock already on it. It's going to have the tool path already on it, and all you're going to have to do is get your geometry in the right position and then pick the geometry. That's how simple we're going to try and make this right now. All right. So first we need to get the tool path. So we're going to go to our mill 2 axis down here. We're going to select our geometry, and we're going to drag a box over it. And remember, Bobcat's usually smart enough to do all this inside set of cuts before it does the outside, but that's not always the case. So you will be able to copy and paste tool paths as well. So there's also that. Now, I'm lazy. I don't want to have to go and pick the start points for all of these. So what I'm going to do is I'm going to click inside this profile chains box here, and then I'm going to tell it to go to the middle of the longest entity. You know, that'll work on a lot of these ones. It may not work on all of them, but if there's a few that are a little wrong, it's better than all of them being wrong. Because a lot of times if you don't click that button, it likes to go to like the starts of chains. So it likes to put it in corners and stuff, as to where this will find kind of the middle of the longest chain. Yeah. Now, if we look at the direction of these arrows, to put our tool path in the areas we want to cut, like in this case, inside of this, we need to compensate to the right side of this arrow. All right, if I click this arrow and it's flipped the other way, now we're compensating to the left side to get in. You know, this one up here, we're compensating to the right. So for most of this, when we're doing these, come on, there we go. When we're doing these, it's totally up to you what direction you cut in. We're not dealing with rotational forces with your plasma like you would be a router. So we're fine to go in either direction. So the thing is, by default, we usually set it up for a right side compensation. So that's what we're going to need. Now over here, I'm going to leave the depth at a 1/2 inch. There's no reason. If you ever decide to cut something thicker, are you ever going to cut a 1/2 inch thick piece of material on that machine?
I hope not.
I hope not either. It's more than capable. It's more than capable. We did probably close to 1 inch of tool steel. I was at a shop with one of these Baileys. We did almost 1 inch of tool steel. It was scary, but it made it through. But if we leave it at a 1/2 inch, the tool path, we don't output the depths. It's a plasma. It's cutting through. So I just want to make sure that the depth that we have set here is going to take care of most of our cases. If you cut 3/8 thick material, this is still thick enough to cut through it, so your simulation is going to work properly. You'll get your results. So we'll just leave it at a 1/2 inch and hit OK. And then hit next. There's our geometry. There's our depth. Nothing really to mess with here. Next, again, we get to the strategy. Now, remember, there's only one strategy we use for this tool path, and it's a profile finish. So we're going to click on Profile Rough, hit this little red X, and we're left with just the profile finish. Next, we get to our tabs. If you're going to use tabs, if you do want tabs for a part, draw them. It's such a simple thing to draw. When you draw a tab, you literally just erase a chunk of the line. It's that simple. We know not to go there. That's how we do it. These tabs they're more for like a router, where as we cut at a certain depth, we'll actually retract the tool, cut across the tab, drop back down so this inside section stays connected to the rest of the stock. Again, you delete a small section of a line, and it'll do the exact same thing for you. So, yeah, there's your tabs. Posting, you shouldn't have to mess with anything on here. So next again. Plasma tool. All right, so this is the biggest thing that we need to make sure is accurate. All right, because if we save this feature and this thing's wrong, everything's wrong in the future. We're compensating too far. It's kind of like your router software only going to a 1/4 inch. But now you're compensating 1/8 of an inch when you should be compensating a 1/16 of an inch or 50,000ths of an inch or something. So the way that you can, I mean, you've taken cuts before with your other software. How do you get it on size? Do you have to, like, in your router software, do you have to offset geometry to make the cut right?
Yes. Yes.
Oh, God, that's okay. So what would you say the diameter of that plasma is as a realistic number? Is it an 1/8 inch?
I think I set it to a 6. Yeah, it would probably come out as an 1/8 inch because I do the offset for the router bit, and then probably an 1/8 inch.
It's usually close to that. And what you can do, a real easy shape you can do, and we could draw it up before I go, is you cut a circle and then you cut a square around it. And you take the measurements of it. And so if you cut a circle and you say that it's an 1/8 inch diameter, if the diameter is larger than that, the circle is going to be too big. If the diameter is smaller than an 1/8 inch, the circle is going to be too small. And you can calculate how much larger you need to go by measuring that circle. Because whatever extra it is or under it is, that's your result. You're going to divide that by 2, and you're good to go. I mean, that's what you have to add to the tool. So that'll be something that if you do run a test, I mean, I can update this thing. Like I said, I'm going to save this for you so, you don't have to do this all again, which will be nice. Feeds and speeds, that's pretty much taken care of at the machine for the most part, I believe, on these Fang Lings, but you don't enter it into the system, right?
No. I do it on the control panel.
Perfect. All right, so we're just going to go next. All right, for our patterns, our compensation, remember the direction we were in to cut the correct side of that geometry is to the right. So I'm going to go to the right and then hit next. All right, parameters, we ain't doing nothing here. So next again. Leads. I usually try and stay, something easy. A blended lead isn't a bad idea, but we got to be small with this. So a right angle lead might be a better choice, especially since we are currently in the middle of every line. So we're in the middle of the longest line of everything, which is kind of a little goofy. But for the length, if it's an 1/8 inch thick, you should be blasting right through. You don't really need much of a dwell time on this material. Are you using your pierces, your delays, and all that stuff? You're getting it right out of the manual, right?
Yeah. Actually, I think the last time we set up the controller.
Wait, what?
The last time you walked me through setting up the controller.
I did?
Somebody did. I thought it was you. Maybe it was somebody. Did I talk to somebody?
It might have been one of the tech guys. It could have been me. I don't. It might have been Bailey too. We don't usually. I can't really do that over the phone. Bailey might be good enough to do that over the phone, but I've talked to their tech support. I don't know about that. So, they might have had you set it up. They've sent me like documents before that walk me through how to set up the thing, and they got really good documents for it. But I was actually cutting at, I actually went to the U.S. Air Force Base in North Carolina, and they had one of these Baileys. Wait, did they have Bailey? Yeah, Bailey plasma. And we ended up, when we were doing our 1/8 inch stuff, we ended up leaving vertical leads on. You could barely tell the pierce point on that thin of material that we didn't even do it. And the benefit of going with vertical is we don't have to worry about areas being too small for me to apply a lead in. It just goes to the position, it blasts on. Now, if you're doing real intricate work, it does sometimes in certain places leave a tiny, you could tell where the plasma turned on, but honestly, we had a big sign we made for them, and I pointed it out, and one of the guys grabbed a file, and 4 swipes with a file, and it was cleaned up. You barely noticed it. So vertical, it's something you could play around with. I felt like when we did our right angles, we were burning more because we spent more time in that one spot because we pierced, and then we moved over, and then we cut,
Yeah.
Honestly, I would say if you're doing 1/8 inch, usually let's try it vertically. Just see what you get. If you don't want to do that, we go with a right angle, but then we got to figure out what's a value that works in most of these situations. Or, we got to go figure out all this stuff. We're vertical. We ain't got to do nothing extra if we can get away with it. So this is what I want you to test. Do this, and then we could turn on, if it doesn't come out good honestly, you could give me a call back and we'll look at it again if we need to. But all we're going to do is change the lead-in type to get it away from the wall.
Okay.
The 1/8 inch is so thin. You're running at what? Probably, 40 amps or 60 amps on? Probably 40, right?
40, yeah. I have, yeah, I've messed around with it a little bit, but 40 seems to be the sweet spot.
Yeah, we were messing with it when I was at the Air Force Base, and it was, it was hit or miss. Now, do you have the clip that goes on yours? The little...
Yeah, the auto scent?
Yeah, the auto set. You have that, right?
Yes.
So many guys have lost it, and that thing is the biggest game changer for setting up these machines. So there's what we're going to go with on the leads. Vertical, this is going to work really well. Again, if you do get something thicker, some thicker material, you will have to add some sort of lead so you can pierce through that thicker material. Right here's our corner types. We ain't ever touching this thing. Right here's our sequencing. I'm going to turn it on optimize. And what optimize is going to do is it's going to pick the best option out of all these. But another option you may need to use is no sorting. Now, no sorting, the way that this one works is it actually runs in the order that you selected the geometry, which if you remember, we dragged a box over it. So
right.
It's going to be random right now, where if you were to go in and hold shift on the keyboard and pick each individual piece of geometry in the order you want them to cut, it'll run in that order. The reason I'm pointing this out is optimize might cut this pocket, then this pocket, then this pocket, but I'm building up a lot of heat while I'm doing that. So no sorting might jump around a little bit more and spread that heat around the sheet. But then I also got to think of the fact that now my tool's jumping around a lot more. I might have some parts, some pieces of my material that after they get cut, they pop up sideways, and now the head of my machine's going to ride through that. So there's no real perfect answer for this. Your table isn't water, is it?
Yes, it is.
You do have the water table. Okay, then let's go with optimized. If you got the water table, you're not building up nearly as much heat as the guys at the Air Force Base. It was just an open bottom table. As soon as you started making a cut, the whole thing would bow, and we'd be throwing weights on it. Oh, it's ridiculous. You might still have that, but yours stays fairly cool, too, because you got that water. All right, so we'll go optimized. Next. And then the advanced feed rates. Now, the Bailey can't use our corner slowdown, so there's no reason to really do it. But if we can figure this out, I'm working with Bailey to see if there's a way to do it. This corner slowdown is specifically made for lasers, plasmas, and water jets. Because as you cut with your plasma, you think about it like an end mill. An end mill cuts straight down. But even an end mill has deflection. Your plasma, as it cuts, it's not cutting straight down. It's cutting straight down, but then it gets blown backwards. And it's actually cutting a little bit behind where the plasma's cutting, because you're blasting through, So when you get to corners, that can mess things up. Like I said, I'm working with Bailey on this, but I got to see where you may be able to go in and enter feeds and speeds here like you normally do at the machine, but without having to use the machine, which is kind of nice. You can just enter them in here, and then on this one, you can tell it when it gets to corners and stuff to slow down a little bit, so that as that cut that's happening, that's again a little bit behind the material or behind the plasma. As you get to this corner, it slows down and it kind of straightens out that plasma, and then it makes that corner. So that's future things. Hopefully I can get it worked out with them. So that's it. I'm going to hit compute. We're going to fit everything to the screen. Looks fantastic. You can see some rapids that seem to be going over some areas. We got some areas that the tool at that size just doesn't fit. There. There you can see it in the ends, it didn't go. But that's fine. We're going to see what it looks like in the simulation. So before we do that, we're going to do a save as. Do you have a specific folder you want to put this in?
Right there is fine.
Okay, good. So let's do the taco logo, and this is going to save it as the BBCD file. So I'll say save, and then start simulation. I think I saw an issue too, or that was a rapid move. We'll see. All right, so right here, we're going to go in. We got our plasma. It's going a 1/2 inch deep, but again, that doesn't really matter to us. We'll speed this up. Length mode, current op segment. Yes, I've been on this computer before, I can tell. So there is our logo right there. And then remember, one thing we can do is over here on this side, if you go down to the measure tab right here, you can change this from off to remove chips. Now, the one we're going to use is remove chips, only keep one part. And what I'm going to do is I'm going to hover over an area like right here where my cursor is now. I want that to stay. I want everything else to fall out. The way we click on it, though, is not with like a left or a right click. We click on it with a middle mouse wheel. So middle mouse wheel click, and that's what the sign's going to look like. There it is.
Okay.
So, you know, it depends on how much you want to get into this. Like, we missed a few little details right there, you know. So
right.
We could go fix them, and by fix them, I mean make them a little bit bigger so that the tool can fit in there, so that the cutter can get into there. You know, same thing with like right here. Notice that little gap we have? That's because this gap is too small for the cutter to go through. So an easy fix for like right here, this little thing, is go throw a fillet on it. Look at the other side. The other side has a fillet. So this side just needs a fillet. I can go to the fillet command, give it something like, you know, a 1/16 of an inch or something. And then I usually use this single corner click because it'll show me right there. There's my preview. That's what it'll do now. Give me plenty of space, but it's a little lower than the other one. So if I want it to look off, I can do that. Or let's go in and just divide that value by 2, hover over it, click that, and now you'll see they're a lot closer to the same height. So if we go into our geometry on our cam tree, so right here with geometry, well, let's do these ones too. I want to get these ones right. So for these ones right here, these little shapes where we're not cutting anything, it really comes down to, you know, how much space do we have? And we can go into evaluate here and say measure 2, and I could go over, whoops, and I could go, come on, zoom in. And I could go over here and try and find, you know, 2 points that are close to across from each other, you know, as best I can. You'll see it's a 1.09, and that's on an angle, so it's probably a little bit smaller going this way. So what you can do is just offset. Offset is under Create 2D. So you go Create 2D, and right here you got Offset. And you take your distance to, you know, you don't want to go too crazy. 1/4 inch is going to be way too much. But if I set a 1/16 of an inch, and I was to hold Shift and pick this shape, now notice it's going inside right now. If I come over here, I could just change this to go to the right. Now 1/16 might be way too big, but actually that looks pretty dang good right there. That's not, I wouldn't think that's too outrageous. And by adding a 1/16, we're getting a 1/16 on this side and this side. We're guaranteed to be able to fit our cutter now. But we could also go in and divide this by 2. And just make it a little bit bigger, and now maybe that little bit bigger is good enough, you know. And you can do all these shapes at the same time when you pick them. So I'm just going to pick all these shapes, and I'll hit OK because we'll do that side first. There we go. So there's those new shapes, and then I'm going to go in and do these new shapes here. That and that one, and hit OK. Cancel out. Now we can go to our cam tree, and again, I'm going to remove the old geometry. So you right-click on the word geometry here. We'll say remove. We're going to right-click on the word geometry again and just say reselect. Now, what I'm going to do this time is on this little area where I redrew, I didn't delete the geometry because I don't know if it's good yet. I'm going to hold Shift and pick all these original lines. And just holding Shift is going to let me chain select them. So I'm holding Shift and picking all these, even though I don't want to machine them. I'm picking them all first, then I'm going to zoom out and drag a box over the whole thing. And that's going to select everything that's not currently selected, and it's going to deselect those lines that I had selected before. So I'm not double cutting them, or I'm not trying to cut them. Again, we click in the profile change, we say middle of the longest entity, we'll hit OK, and we'll go ahead and compute this. So we'll compute all toolpaths. We just want to make sure we see the toolpath inside the geometry. You can see we now have cuts happening inside of there. Perfect. So we should actually be cutting everything. This is what threw me off earlier. Look at that, crazy. What is going on there? I don't know why it's going so far, but something like that, you know, we might be interested in. Let's do another little fillet. Let's just fillet these guys right here. Yeah, so you get trimmed down to there, bud. You and you. And then for this one, I'm just going to right-click on geometry and say reselect, because the only thing I need to reselect is these edges here and there. And then we can hit OK and recompute, and that should be good to go. Much better. You know, we got the same thing going on down here. I'm not worried about it, though. So there we have it. All right, let's give it a save. We can close this measure entity box. This will pop up anytime you take a measurement using the measure entity buttons. And then we'll start the simulation. Now, I believe, and I'll try and turn it on. Let's see if this one works. There was this one right here. It's called remove chips based on volume. And so we're going to say automatically remove the chips during the simulation. And we're going to say remove all small chips, keep the largest one. All right, let me hit refresh there. All right, so now as we run, it should be disappear. The cuts, the little pieces of geometry that we cut out should disappear. There we go. Kind of like they'll be doing in the machine when they fall into that pit of water, and then you got to dig them out later on. You know?
Yeah.
Just
That's
like
why I
that.
have students.
Yeah, exactly. Lucky you. My buddy he worked here at Bobcat. We grew up together, and then he moved back up to Illinois, where we're from, when one of his dad's buddies who runs a machine shop found out he had some experience with programming. And so he went back up there, and he's got like a 60 by 30 plasma table. The thing is absolutely ridiculous. It's huge, but the first 3 weeks, oh man, it got rid of the stock. All right, restart. Stupid thing. All right, I thought that would work, but the stock's the biggest piece of material when it's all said and done. But the first 3 weeks he spent just cleaning out the plasma. The guy that was there before him heard that he wasn't going to be doing the plasma, so for the 3 months before my buddy showed up, he just didn't do anything. He didn't clean it at all. So it was 3 months worth of slag in a proper daily used kind of machine shop setting. Oh, it was ridiculous. So there it is. Looks a bit better now that we got those little details in there. Looks good. All right, so now we're at the point to post it. All right, we're ready to make the G code. The simulation looks good. We got the Fangling post processor, and so we'll just say post. And then right there's the code. We got a G92, so wherever the plasma, so basically as long as the origin, you set the plasma in this bottom left corner, when you hit go, it's going to start making those cuts. So we'll do a save as on this. I'll throw it in that same folder. It's going to be a .cnc here. I am going to get rid of this one that's on there. I don't think the machine's going to want parentheses very much. They're really dumb controllers. So, all right, so save that. And then now let's look at what I was talking about to make this whole thing easier, to make this whole thing better. You're always going to be cutting. The biggest you're going to go with is a 4x4 sheet, right?
Correct, yeah.
Okay, cool. So we're going to set up every job as if it's a 4x4 sheet. Even if you're only going with a 2x2, all you got to make sure is that your bottom left corner is in the bottom left corner of the machine. Or wherever you start the machine from is the bottom left corner of the sheet. The whole thing with your G code is you have a G92. There is no home position for this. G92 just tells the machine wherever I'm sitting when you hit go is where I'm going to start from. So if you started accidentally, like a part like this, if you were to start it in the middle of the table, if this is the table, if you were to start it on accident here, this part's too wide. You're going to hit limits over here. So it's going to go from wherever you hit go from. But as long as if you want it to come out the same as what you see in Bobcat, you're going to want whatever sheet size you use to have the bottom left corner tucked into the bottom left corner of the machine. All right? And then you should always get the right results. So now what I'm going to do is I'm going to right-click on this milling job, and I'm going to go ahead and say Save as Job Template. All right, and this is going in the Templates CAM job, so this is going to be my plasma let's do this. We'll say 4x4 stock plasma job. Okay, so you got 4x4 stock, and it's a plasma job. So save. And so let's start from scratch here. So I'm going to right-click and delete this milling job, delete the whole thing. All right, so we got our drawing into Bobcat. We've gone in, we've made any changes we needed to make. I'm going to get rid of all these extra things we got right here real quick. So we've done our CAD work. The kind of final step is get this part situated inside of this area. And it's simple. Remember, you can go up to utilities and you can use translate. If you're not worried about having the exact 1-inch margins like I was doing earlier, what you can do is just drag a box over the geometry. It finds the exact center of that geometry. And if you know how wide it is and how tall it is, you can just enter values, right here directly in, or you could just click this button and move it wherever you need to move it to. So again, it goes into that area within that stock that we're going to have. All right?
Yeah.
Now we're going to go over here to the cam tree. So instead of right-clicking on this and saying we want to do a new job, from now on we're going to go to Job from Template. When we do this, we have our 4x4 stock plasma job. We're not going to even run the stock wizard. All we're going to do is hit OK. And that is going to create the stock, and it's going to load in that toolpath we made. So all I have to do is pick the geometry, and you can tell because there's that little red plus sign right there. So we right-click, we say reselect, we drag a box over the whole thing, click in the chains. If you want to do the middle of the longest chain, that's what I usually do for these ones. You go to the middle of the longest chain, you hit OK, you compute the toolpath, it's done, we're ready to post at this point. You can simulate, you can post. So any geometry you do, that's how it's going to work now. You load in that job, you pick the geometry, and you run it again. Now here's the best part. What if you go and watch this thing in the simulation, you see something wrong? Something happens with, the order of operations gets messed up. You got the outside getting cut before the inside, which is something we never want to happen. And it does happen once in a while. And there's usually a cause to it. It's usually something with the geometry, but I'm usually too lazy to figure it all out, especially when the fix to it is so simple. Instead of doing the outside with this first feature, we'll just do the outside as its own feature. So for this geometry, I'd say reselect, and I'm just going to hold shift and pick this outside edge again, and it's going to deselect that one. I'll hit OK, and then I'm going to go ahead and hit compute, and I'm going to make sure that all these toolpaths show up on the correct side, which you'll see some of them. Oh yeah, no, we're all good. We're all good. I was looking at the wrong side of those lines. So those are all still on the inside, which is perfect. Now I can right-click on this feature 2 axis here. I can go right down here to copy, and then I can right-click on my machine setup 1 and paste this feature. Do you want to use the same top and depth? Yes, I always do. Now again, just like when we loaded in that template, it's going to have the geometry and then the geometry once again. So right-click, say reselect, I'm going to hold shift, pick it, check my chain direction, say middle of the start point. I don't even know where it is right now. I'll put it down here in the middle. To the right puts us on the correct direction. We're good to go. We hit OK. We hit compute. And now it's going to cut the outside as a separate set of toolpaths so that there's never going to be, an issue with that. And you can copy and paste that toolpath as many times as you want, and it's going to be just fine. So there we go. And that's ready to post. So, it's kind of cheating now. You really don't have to do much for the cam because it's all kind of done, but that's the goal here. We want to be able to cut parts. So this is going to make it so all you got to do is load that cam job, that job from template. Again, you go job from template. You'll pick the one job. It's the only one we have. It only has one toolpath in it right now, but you can copy and paste that toolpath as many times as you want. It works out just fine. The other one last thing I'll tell you real quick is center line cutting. So a lot of these plasmas, especially when you find stuff online, they'll have like small details, like the wrinkles of someone's face will just be a line cut in. And if you were to go and run it with this kind of tool path where we go around it or inside of it, it ends up making it way too big. So you'll have just a single line that you just want to pierce, cut, and then exit without doing like a full profile. You can do that, and it's through these same features. You pick your geometry. So any geometry you just want to run the center line of, just put the center of the tool on it and run it. The only change you have to make in Bobcat to make it work is on the patterns page here, you turn your compensation off. And that's going to take the center of the plasma and run it along those lines. That's good to use when you get real fine detail and you're only cutting like one line at a time.
Gotcha.
But for compensation to the right should be the setting we use for just about everything. And yeah, there she is. Save this again. We already posted and saved the code, so we're good there. And that's really it. When you're done with posting, you can actually shrink it back up by don't click the X, click the little thumbtack, and it'll throw it back over here on the wall.
Okay.
All right. So is there any questions? Anything I did that you don't get? What do you got? Let me hear it.
No, that looks good. Like I said, I was just, failure to launch on it, really.
Yeah, for sure. And there's, I wanted to pull up this thing for you just so you have it. So if there is anything you need to fill in on, a lot of your questions, if you call tech support, we're going to help you. You're a school anyway, so they're going to give you a hand. But we did let's go bobcatsupport.com. And I'm actually interested to see if this works on yours because the videos were missing for me earlier. So I don't know if they were messing around with it, updating some. So this is our free support site. It's where you can find posts and stuff. You don't need any of that. But up here we can go to training. And right down here we have recorded virtual events. So I can click that and wait for it to load up. And then I want to say it's all the way at the bottom, the laser plasma water jet. We'll see. What are they going to be drawing in to create parts?
We use Autodesk Inventor or AutoCAD, depending on the parts. I guess Inventor we use more for 3D parts, and AutoCAD.
Do you guys have mills? Do you guys have mills there as well, or just do you have a router? Like for
we have a router which we only use with wood. We have a mill. We have a lathe. And then, of course, the plasma table.
And what are you guys running all those with? Autodesk?
All of the drawing happens in the Autodesk suite, just because that's where our standard aligned is. And then we use, I even forget what the router table used, because it's actually in the shop next door. So the guy next door is responsible for that. But then we use Denford for the mill and the lathe.
Okay. So on this part of the site, go ahead.
It's the native Denver.
It's the one. Yeah, made for them. Cool. Hell yeah. All right. So this is just what I wanted to show you. I just so in case you need a little refresher. This bottom one here, he's no longer here, but it's a good one. It's in your version 33. But I did one, looks like January or so, in version 34. There isn't a difference in between 33 and 34 as far as the laser plasma water jet is concerned. There's no major difference. So if you watch this one, I think this one's an hour long or 2 hours long about. I'll probably do some drawing in there. I can't remember what I did. This is almost a year ago. There might be some drawing in there as well, but it should be talking about anything that you might be interested. But again, at this point, as long as you remember these steps, you should be good to go. Also, when I send you the recording today, you can download it. You're able to download it so you can save a copy of it and put it wherever you need to put it.
Yes, and I will do that this time.
That's why I was pointing out. Make sure you do it this time. I don't anticipate any more problems with that whole thing, but you never know. IT and such. All right, so any final questions? I'm going to end the recording if not.
Nope, I think we're good.